Welcome pre-cal students to the help video, help homework video, page 36, numbers 17 through 29. That should be a grand total, or the odd, 17 through 29 odd, that should be a grand total of, let's see, 7 problems. Okay, so let's go ahead and get started. Open your books if you need to. We're starting off with number 17. We're going to multiply these two expressions together. Are you ready? Here we go. I'm going to go ahead and start with this first fraction right here. And notice the denominator, I'm circling it for you, it's x minus y squared. This is not factoring, but I'm going to go ahead and write it like this just so we can see both sets of parentheses. Now let's go ahead and deal with this top part of the fraction right here. Remember, when you're multiplying rational expressions, the steps were factor the numerators and the denominators as much as possible, and then flip any fractions if you're dividing. And then step 3, do all the cross-canceling and reducing you can do, and then go ahead and multiply. So the first thing we want to do is factor as much as possible. Now, as you guys can see, there's really no factoring I can do to this fraction over here. I'm just going to go ahead and bring it down. So 1 over x plus y, okay? However, I can do some factoring to this binomial. Step 1, there's nothing common to pull out. Am I left over with a bi or a tri? Well, I'm left over with a binomial. I do know the square root of this term. I do know the square root of this term. So I'm dealing with perfect squares. When you're dealing with perfect squares, the first term has to be positive, and it is. The second term has to be negative, and it is. So you go ahead and write 2 sets of parentheses. There we go. Now, the square root of x squared is x, so I'm going to put an x here and an x here. The square root of y squared is y, so I'm going to put a y here and a y here. Make one positive, make one negative. And now I'm ready to start cross-canceling. For example, x plus y would cross-cancel with x plus y. And then look, I can reduce right here. X minus y would reduce with x minus y. Now everything up here is gone, so I'm going to put a 1. Everything down here is gone, I'm going to put a 1. And now we're going to multiply across. 1 times 1 is 1. And x minus y times 1 is just simply x minus y. Very good. Moving on to number 19. Now, again, step 1 would be to factor as much as possible. So let's start off with this part right here. And let's factor this out. We have x squared minus 2x minus 35. All right, nothing common to pull out. Next, I notice I have a trinomial with a lead coefficient of 1. So I'm going to list out all the multiples of negative 35. Of course, I'm not going to list them all out. By now, we know how to do that. And the 2 we would use would be a positive 5 and a negative 7. If you multiply those, you get a negative 35. If you combine those, you get a negative 2. So the factorization would be x plus 5, x minus 7. Okay? And that's the top part of the fraction right there. So I'm going to put a fraction bar right here. And I'm going to grab this factorization. I'm going to drag it up here. All right, there we go. Now let's go ahead and let's see if we can't factor this part right here, the denominator. All right, so what I would have would be 2x cubed minus 3x squared. The first thing you do is always pull out what's common. I cannot factor anything out of a 2 and a 3, but my x's, I can pull out 2 x's, and that will leave me with 2x minus 3. Okay, x squared times 2x, 2x cubed, x squared times negative 3, negative 3x squared. Now, you're left over with a binomial right here. Normally, you could factor those, but in this case, I do not know the square root and or the cubed root of these two terms. So there's nothing I can do with that binomial. So I'm done factoring it, and we're going to move it right over here. Now let's take a look at this part of the problem. Let's see if we can't do some factoring there. 4x cubed minus 9x. Now, there's nothing I can factor out with the 4 and the 9. However, there's 3 x's here and there's 1x here. I can pull 1x out. So when I do that, I'm left with 4x squared minus 9. Okay? Now, look at your binomial. I do know the square root of this term. I do know the square root of this term, so I'm dealing with perfect squares. When you're dealing with perfect squares, the first term has to be positive, and it is. The second term has to be negative, and it is. So I can factor this binomial into 2 little parentheses. And I would have the square root of 4x squared is 2x. So I put a 2x here and a 2x here. The square root of 9 is 3, so I put a 3 here and a 3 here. And then a positive and then a negative. All right. Now that's our factorization. Let's go ahead and pull this up here where it should go. Do some erasing. There's our fraction bar and our multiplication dot. Now let's see if we can't do some factoring with that expression right there. 7x minus 49. Now pull out what's common. That would be a 7, and you're left with x minus 7. X minus 7. Okay? So again, factor out a 7, and we're left with x minus 7. All right? Now let's go ahead and let's follow our steps. Step 1 was do all the factoring you can possibly do. Step 2 was to flip any fractions you need to flip because you're dividing, and we don't need to flip anything. Step 3 is do cross canceling. So here, and reducing. So here we go. We've got an x minus 7 over here and an x minus 7 here. There we go. We've got a 2x minus 3 right here and a 2x minus 3 right here. So we're cruising right along. Look at this. I've got an x squared group here. Look at that. And an x right there. I can take 1x away from both of them. So if I take 1x away from x squared, I'm left with an x. And if I take 1x away from this, it's totally gone. I'm not seeing anything else that cancels here. Okay? Please don't try to cross off your x's like that. Okay? One's a binomial, one's a trinomial. Now, we take our top, x minus 5, times our top, 2x plus 3. So x plus 5 times 2x plus 3 all over x times 7, 7x. I'm not going to make you do all this multiplication up top. That's just busy work to me. You've already showed me you know how to do that, so that's good enough. And we're moving on to the next problem. Okay, step 1, we always do our factoring first, so I'm going to start with this part right there, and that would be a squared minus a minus 6. There's nothing you can pull out that's common. We have a trinomial with a lead coefficient of 1. So if I listed out all the multiples of negative 6, I would want to use this group right here because a positive 2 times a negative 3 is a negative 6. And if you combine those, you'll get a negative 1, which is your middle term. So we're dealing with a plus 2, a minus 3. Okay? Let's go ahead and highlight that, and let's draw. Oh, that's not what's supposed to happen. And let's drag that over here. And there, we have factored the numerator. Now let's go ahead and factor the denominator right here. So we have a squared minus 7a plus 12. Now, there's nothing common I can factor out. I have a trinomial with a lead coefficient of 1, so I'm going to list out all the factors of 12. I'm not going to take time and do that. It should be negative 3 and negative 4, because if you multiply those, you get a positive 12. If you combine those, you get a negative 7. So my factorization would be, I'm so used to using x all the time, my factorization would be a negative 3, a negative 4. All right, that's your factorization. So let's grab it real quick and drag it up here, and let's continue on. Now, and that's not what I wanted to do. There we go. And there we go. Now let's go ahead and work on factoring this. So I have a squared minus 2a minus 8. All right, nothing common I can factor out. I've got a trinomial with a lead coefficient of 1. So my numbers I would want would be a positive 2 and a negative 4. When you multiply those, you get a negative 8. When you combine those, you get a negative 2. So a positive 2, a negative 4. There's the factorization. I know I'm going pretty fast now, and I care about all the students I teach, but by now you really should know how to factor, okay? We had this in Algebra 2, and I've reviewed it now very well, if I do say so myself, in your previous videos. All right, now let's go ahead and see if we can't factor this trinomial, a squared minus 3a minus 10. Nothing common I can factor out. Step 2, I've got a lead coefficient of 1 with a trinomial. List out all the factors of negative 10. If I did that correctly, I would have a positive 2 and a negative 5. When you multiply those, you get a negative 10. When you combine those, you get a negative 3. So my factorization would be a plus 2 and a minus 5. So there we go. Let's go ahead and grab this factorization and drag it to where it's supposed to go. Looks like I've got a little extra piece there we didn't need, that plus sign. See if we can't squeeze that out. There we go. And get rid of that. All right, and now students, we have factored everything, which is what step 1 is. Step 2 says flip any fractions that need flipped. Well, there's no division sign, so nothing needs flipped. Step 3 is start cross-canceling and reducing. So I've got an a plus 2 here and a plus 2 here. I've got an a minus 3 here, and that would reduce with my a minus 3 here. I've got an a minus 4 and an a minus 4 over here. Nothing's left here, so I'll put a 1. Nothing's left here, so I'll put a 1. 1 times a plus 2 would simply be a plus 2. And 1 times a minus 5 would simply be a minus 5. And we're already almost halfway done. Okay? Let's go ahead and move on to number 23. Now we're getting to some division, okay? So that'll be a good little challenge for us. Okay, let's go ahead and go through and factor everything as much as possible. Let's start with this right here. M squared minus n squared. Now, first of all, there's nothing common you can factor out. So you look at what you have and you say to yourself, okay, I've got a binomial. Do I know the square root or the cube root of both terms? Well, I know the square root of both terms, so we know we're dealing with perfect squares. I know the first term is positive and the second term is negative, which is good. So I can factor this. So I go ahead and I put 2 little parentheses. The square root of m squared is m, so I put an m here and an m here. The square root of n squared is n, so I put an n there and an n there. Make one positive, make one negative. So I just factored this right here. And so I'm going to grab this factorization. And I'm going to yank it up here. And now let's continue on. Now we want to do some more factoring if possible, but you're going to see it's not possible. Look at this binomial. There's nothing common you can factor out. Do I know the square root or the cubed root of either one of these two terms? The answer is no, so there's nothing you can do with that. Look at this binomial. There's nothing common you can factor out. I do not know the square root or the cubed root of these two terms, so there's nothing I can do. Okay, let's take a look at this binomial. There's nothing common I can factor out. It's just like this one over here, and I don't know the square root or the cube root of those two terms, so there's nothing I can do. So really, I'm just going to bring down my r plus s, and I'm going to bring down my division sign, and I'm going to bring down my m minus n, and then my r plus s. I've done all the factoring I can do. Now step 2 says flip any fractions that need to be flipped. Well, students, this m, we have this fraction divided by this fraction, so we're going to flip the second fraction. So I'm going to bring this down here, and I'm going to bring this up top, and there. I have flipped the fraction. Step 3 says, oh, and by the way, I forgot, when you invert or flip the second fraction, you then multiply. So I'm going to make that a multiply symbol. And now step 3 says cross cancel and reduce as much as possible. This is r plus s. It's a whole group. That would cancel with r plus s. So I have nothing left here. I'll put a 1. Nothing left here. I'll put a 1. M minus 1, this whole group here would cancel with m minus 1. Nothing left here, so I'll put a 1. And so I have m plus n times 1, that's m plus n, over 1 times 1 is 1. Now you are more than welcome to leave your answer like this right here. I have no problem with that. Of course, though, anything over 1 is just itself, so m plus n over 1 is just m plus n. So I would also accept that answer. Okay, moving on to 25. Again, we're going to factor until we're, sick and tired of factoring. So here we go. Let's start off with 3x plus 12. We're going to factor 3x plus 12. First of all, you cannot pull out any x's, but you can factor out a 3. So you'd be left with x plus 4. 3 times x is 3x, and 3 times 4 is 12. All right, so we factored the numerator. Let's go ahead and highlight this and drag it up here. All right, let's go ahead now and see if we can't factor this right here, 2x minus 8. Always pull out or factor out the common factors. I can pull out a 2. There's no x's I can pull out. So if I factor out a 2, I'm left with x minus 4. 2 times x is 2x. 2 times negative 4 is negative 8. And so I Oh, I apologize. I know although you should know this by now, but I really have got to do a better job of going over why I did not continue to factor. After you pulled out a 3 right here, you were left over with a binomial. Neither one of these two terms were perfect squares or perfect cubes. Well, you know the square root of 4, Mr. Earhart. Yeah, but you don't know the square root of x. You have to know the square root of both or the cube root of both. Here we pulled out a 2, and look at your two terms left over right here. You do not know the square root of both of those or the cube root of both of those, so you cannot factor those binomials any further. Now, there's no more factoring we can do, but we do have x plus 4 to the second power. I'm going to go ahead and do this. I think students see it better. I'm just going to go ahead and put x plus 4, and then for the denominator, x minus 4, x minus 4. So there, step 1 is done. We have factored all that could be factored. Step 2 says flip any fractions that need to be flipped. And so we're going to do that right now. We have a division symbol right here. Do you see that? And because we have a division symbol, we're going to pull it down here, and we're going to put a multiplication in, and we're going to flip the second fraction. So here we go. Let's see if we can't move stuff around here. That's going to go up top. This will go down here. Looks like I missed a little bit. All right, there we go. Now, we have flipped our second fraction because we had a division sign here. Once you flip the second fraction, you then make it multiplication. And students, I'm seeing all kinds of stuff. X minus 4 would cancel with x minus 4. X plus 4 would cancel with x plus 4. So you're left with 3 times x minus 4. So 3 times x minus 4. That's for your numerator or your top. And then 2 times x plus 4. 2 times x plus 4. Now, that's an acceptable answer. I have no problem with that. If you want to take the 3 and multiply it through and write 3x minus 12 up top, I have no problem with that. If you want to take this 2 and multiply it through and write 2x plus 8, I have no problem with that. Either one of those two answers are totally acceptable. Okay, moving on to number 27. We have to factor x squared minus y squared. So x squared minus y squared, and we get that from right here. So x squared minus y squared, nothing common we can pull out, but they're both perfect squares. We know the square root of both of those, so the square root of x squared is x, and the square root of y squared is y. So an x and a y, make one positive, make one negative. Sorry about that. All right, and now we're going to continue up here. So we're going to grab this and drag it here and put a line there, and let's continue on. Now let's go ahead and factor x cubed minus y cubed. There's nothing common you can factor out. However, this is a perfect cube and this is a perfect cube. We know the cube root of both of those. Remember what to do? You put a little parentheses and a big parentheses. The cube root of x cubed is x. The cube root of y cubed is y. You bring down your negative sign, and now you take this x here and you multiply it times itself. So x times x is x squared. Then to get your middle term right here, you take this term and you multiply them together. So x times y is xy. And then you take this term here and you multiply it by itself. So y times y is y squared. Now, whenever this is negative, everything over here is positive. And there, we have done it. We have factored completely this denominator, so we're going to bring it right over here, and we're going to erase that and move on. Now, we might be able to factor this right here. I'm not sure if we can. I don't think we can though, but let's see. Let's go ahead and try. X squared plus xy plus y squared. Now, students, first of all, there's nothing common in every term you can factor out. Secondly, I have a lead coefficient of 1, so I'm looking to list out factors of 1. But when you list out factors of 1, 1 times 1 and 1 times 1, positive times a positive, negative times a negative, none of those are going to add up to a positive 1, none of them. So this cannot be factored. There's no factors that you can list out for 1 that will add up to that middle term right there. It just can't be done. So that cannot be factored. So I'm going to go ahead and put multiplication. I'm going to put x squared plus xy plus y squared. Now let's see if we can't factor that expression right there. All right, so here we go. I would have x squared plus 2xy plus y squared. Now watch this carefully, please. There's nothing common I can factor out, so moving on. Next, I would say, okay, I've got a lead coefficient of 1, which means that I'm going to list out all the factors of 1 right here, all the factors of 1, and see if any of those add up to 2. Well, I think a 1 and a 1. A positive 1 times a positive 1 is 1, and 1 plus 1 is 2. So, I'm going to go ahead and do my factoring. I'm going to go ahead and put 2 little parentheses. Now, be careful with what you put, okay? I have an x squared here, so I've got an x and an x, and you're used to putting the 2 numbers, so x plus 1 and plus 1, which is fine, but don't miss this, students. You're used to having just a number here, like the number 1, and you don't have just a number there. You have y squared. So yes, you're going to put a 1 and a 1, but you're also going to put a y and a y because of the y squared. When you multiply x times x, you want to get x squared. When you take 1y times 1y, you want to get y squared. So this here, this expression right here, would be the proper factorization for this denominator right here. This denominator right here. All right, so we have done all the factoring that's possible. Step 2 says flip any fractions you need to flip due to division. I don't see any division. Step 3 says cross cancel and reduce. I see an x minus y that would reduce with an x minus y. I see this trinomial here, x squared plus xy plus y squared. That entire thing matches this group entirely. So there's nothing left here, I'll put a 1. Nothing left here, I'll put a 1. Notice I have x plus y, and down here I have x plus y. Yes, there's a 1 right here, but I could put a 1 here if I wanted to. It's not a big deal. So x plus y cancels with x plus y. Nothing left here, so I'll put a 1. So 1 times 1 is 1, and 1 times x plus y is x plus y. If you want to put a 1 here or a 1 here, that does not matter. You're welcome to. And that is your answer. One more and we're finished, so good job. Now this is going to be pretty difficult here. I'm not going to lie to you. There is no factoring here we can do. There's no factoring here we can do. Trust me, you can pull it down, try all the factoring tricks I've taught you. None of them will work. We can factor this, but it's going to be really, really difficult. I did choose this difficult problem to make you think. I doubt if I'd give you one on a test, but it still is good for you to think a little bit. Okay, now please watch what I'm going to do. If I had an x here so that it was x squared minus z squared, you would say, oh, we know the square root of this and we know the square root of this. And so you'd put your little parentheses, you'd put an x here and an x here and a z here and a z here, yada yada, so on and so forth. Well, you don't have an x, but you have an x minus y, and it's raised to the second power. So you do know the square root of this whole term, and you do know the square root of this whole term. So we're going to treat it that way. So we're going to say to ourselves, hold on one second, please. I want to get rid of those circles. So we're going to say to ourselves, okay, I know the square root of z squared is z, so I'll put a z here and a z. What's the square root of x minus y squared? Well, it would just be x minus y. Think about it. If I had x squared, the square root of x squared would just be x. It's like the 2 isn't there. It would just be x. So the square root of x minus y squared is x minus y. So I'm going to go ahead and put x minus y, x minus y. Don't forget to make one z positive and one z negative. And there, you did it. So this whole numerator right here that's circled up here, I'm erasing it now, that whole numerator now factors down to this right here. So I'm going to drag this right over here, and that now is the top part of that fraction. Now, maybe you can try the denominator on your own. I mean, give it a shot. It's done just pretty much the same way. We have x plus y in parentheses, quantity squared, minus z squared. I do know the square root of this expression. I do know the square root of this expression, so I'm dealing with perfect squares. So when I'm dealing with perfect squares, I put my 2 parentheses. The square root of x plus y squared, well, again, if it was just x squared, you know the square root of x squared would just be x. It would be like this 2 wasn't even there. So it's the same thing. The square root of x plus y squared would just be x plus y, so you write x plus y there and x plus y there. The square root of z squared would be z, so you put a z there and a z there. Make one positive, make one negative. So there, you totally factored this denominator right here. I'm going to circle it for you. Just factor this denominator right there down to that right there. Okay, so with that in mind, we've done all the factoring we can do, and I'm going to go ahead and save some time. I haven't skipped steps very often. I'm going to go ahead and skip a step. See this division sign right here? I'm going to go ahead and put a multiplication, and then when I bring this fraction down, I'm going to go ahead and flip it now. So the bottom, x plus y minus z, if you can see that right there, I'm going to put that up top in the numerator. And then the top here, the numerator, I'm going to write that down in the denominator right here. We're going to go ahead and flip this fraction. So x minus y plus z. Now, start canceling. Let's see. X plus y minus z. Here it is. X plus y minus z. X plus y minus z. So put a 1 right there. X minus y plus z. Well, that cancels perfectly. Put a 1 there. With x minus y plus z. So you're left with this parentheses here times 1. So x minus y minus z all over. And then you're left with this parentheses here times 1. So x plus y plus z. Now I know some students are like, cool, let's start crossing off the x's and crossing off the y's and the z's. Hold on, guys. You can only cancel like that when you have one term up top and one term in the bottom, and we just don't have that. You've got to leave this alone. You cannot reduce that. Okay, that is your final answer. As always, I hope these homework videos help. Contact me, call me, email me if you have any questions.